So before I start the notes, I want to go over, if I have pi and I want to switch it to the equivalent to something over 6. So if I multiply the 1 times the 6, then I have to multiply the top also by 6, right? So you get 6 pi over 6. And that makes sense because the 6's cancel out and it leaves me with pi. So if I was going to do this with 4, you would have 4 pi over 4. And if I did it over 3, it would be 3 pi over 3. Okay? But if I wanted 2 pi now, and if I want to put this over 6, so I multiplied the 1 times the 6, so what do I have to multiply the 2 by? So I get 12 pi over 6. What are you guys laughing at? See, this is why we're doing this. But look, so the 12 divided by the 6 gives me 2. And the way I found it, if you double your 6, that went on top, right? So if I'm going to double the 4, on top would be 8. And if I'm going to double the 3, it would be 6, right? Okay. So let's keep that in mind. All right, so an angle in standard form is theta. An angle in standard form is theta. An angle on the coordinate plane is in standard form when the vertex is at the origin and one side is on the positive x-axis. The one side on the x-axis is called the initial side. And the final side is called the terminal side. Counterclockwise, or going this way, results in a positive angle. But going clockwise, going this way, results in negative. So the most common unit of measure for angles, which you spent most of your time in geometry doing, is the degree. And a full circle, one full revolution, is 360 degrees. And if you look at the circle, if you notice it's cut into 4 by my axis, right? I have the x-axis and the y-axis, which gives me 4 quadrants. And so we have quadrant 1, 2, 3, and 4. And since the 360 is divided in 4, that means you get 90 degrees each quadrant, correct? So if I start here and I rotate up, that's 90 degrees. That's 90. If I go another 90, that's 180. If I go another 90, it's 270. And one more 90, it takes me back to 360. All right? Now, if I started here and I went the other way, then this would be negative 90, negative 180, negative 270, and negative 360. It would just go the opposite way. Does that make sense? We're all good? Okay. So if I'm going to draw an angle, 135. So I know it has to start here. So 135, this is 90 degrees. What's this down here? So I know it's between 90 and 180, correct? So it's going here, so I get this. Yes. But I know it's 45, right? So it's like halfway between 90s. Does that make sense? Okay. So minus 140. Minus 140. First of all, this time I have to go the other way. This way is positive, this way is negative. So if I start here and I go here, that's 90. Do I want to go past this one? No, because that's minus 180. So I'm just going to go here. And that's the minus 140. Right there. So does that make sense? These two make sense now? So here I have 495. So first of all, how much is all the way one time around? All right, so I know I'm going to subtract 360. And if I subtract 360, I get 135 degrees. So I know I'm going to start here. Here's my line. I'm going to start here, and I have to go all the way around once. But then how many more degrees do I have to go? So this is 90. Am I done? So I have to keep going. So this would be my angle. So you make like a little twirly thing. It's kind of cute, right? I like a little decorating here. Yeah, a little snail. Get your snail going. Get your snail on, okay? Circle it around. Okay, so that's what you did most of the time in geometry. What we're going to spend almost all of our time doing is radians. And a radian is a unit of angle measure that's based on arc length. 1 radian is defined as the measure of the angle formed when the radius is equal to this. Okay, when the radius is equal to this. So 360 degrees is going to equal 2 pi, and 180 degrees is going to equal pi. So when I'm converting from degrees to radians, I need a pi in my answer. I have to have a pi. So that means I'm going to multiply by pi over 180. When I go from radians to degrees, the degrees means I don't have a pi in my answer. So I'm going to flip it upside down and multiply by 180 over pi. So when I'm converting, I'm always using the pi over 180 or the 180 over pi. So I have 60 degrees. So first of all, it wants to know the quadrant. So 60 degrees, which quadrant is that? That's the first quadrant, okay? So next, I'm going to multiply by pi over 180. And when I do that, the zeros cancel out, right? Because I divide out by 10. So I get 6 pi over 18. And that reduces to pi over 3. And that's your answer. And your answer is going to have a pi in it. And you don't want to get rid of it, okay? So 160, I'm going to multiply pi over 180. So which quadrant would 160 be in? Second. So the zeros cancel, and I have 16 pi over 18. And that reduces. So if I divide by 2, I get 8 pi over 9. Or 3, probably. Oh, and before I forget, do not be gone on Thursday. Don't be gone. We are doing arts and crafts that day, and everybody better be here on Thursday. Put your hand down. Put it down. Why? Skip the testing and come and do arts and crafts. I'm not talking to you two now. We are doing arts and crafts, and you are going to like it. It really is a bad day to miss. No, we're not, and I'm so depressed. All right, minus 330. Now I'm depressed. Yeah. I'm going to cry now. I'm crying. Yes, this is your first final. Okay. I'm crossing out the zeros because I divided out by 10. What? Yes, it is. So she's answering which quadrant is it in. So minus 330 means it comes all the way around here, so it's in the first quadrant. So now what am I dividing by? So I get negative 11 pi over 6. So this, we do just the opposite. It's 180 times pi.
What's grad school? That's college? I didn't know you called it grad school. I thought college.
That's grad school.
Oh, see? I knew it was just college.
All right. Shh. So everybody double check and make sure these are what you got. Yes? Okay. So listen, so far we've done the initial and terminal side. So the initial side is on the x-axis and the terminal side is your final side. Degrees to radians, you're using 180 over pi or pi over 180, right? So we have these three things left to do today. 3. 420. No. No, I'm not nice like that, ever. Okay, shh. So next, go to the very bottom on your notes. Go to the bottom where it says quadrantal. So a quadrantal means it's an angle that's one of the xy where it crosses. So at 0 degrees, it's 0 pi. All right? If I go up 90 degrees, it's pi over 2. If I go another 90, it's 180 or pi. If I go another one, it's 270 or 3 pi. And one more, it's 2 pi or 360. Okay? So the quadrantals are the 90 degrees. So where the x and the y cross. So it's a fancy name for where the x and y cross on the 90s. Okay? So look, we've done this, this, and this. Okay? We have these two left to do. Okay, so everybody look up here for a minute. If I draw this angle, it is, but it doesn't matter. If I draw that angle, if I drew this angle, this was positive. If I go negative, they share a terminal side. And we call that coterminal. Okay? One went positive and one went negative. Do you see that? And they share that side. That's what coterminal is. So if I drew like this, if this is my first angle, that would be the coterminal angle. Does that make sense? Okay. Yes or no? Do you see this or not? So if I look at the two of them together, how much do they add up to? 360. So if I know one, can I subtract 360 and get the answer for the other one? Right? Okay. So if I'm given 305, I want to know if negative 55 is a coterminal. So I'm just going to take 305 minus 360. And if you do that, you get negative 55. So yes, these are coterminal angles. So for the next one, if I subtract, I get negative 330. So are these coterminal? No. So for this one, I subtracted 360. What am I going to subtract here? I'm going to subtract 2 pi because that's the same as 360. So if I have pi over 4, I want to subtract 2 pi, but it has to be over 4. So I have to double the 4, and I get 8. So 1 pi over 4 minus 8 pi over 4 gives me negative 7 pi over 4. So are those the same? No. All right, we're going to skip the next one. Okay. So the first one said, just tell me if they're coterminal, yes or no. So this one says give 2 coterminal angles. I want a positive and a negative. So up here, I subtracted to get this way, right? So if I went here and I added 360, would that be the same? Watch. Let me get a different color. Look, if I went this way, if I start here and I add 360 degrees, is that the same? Yes or no? Did it end up in the same place? It did. So here, I'm going to add and subtract 360 or add and subtract 2 pi, depending on if it's in radians or degrees. So degrees to radians, it's going to be pi over 180 or 180 over pi. The quadrantal was all of the 90s. And the coterminal, it's plus or minus 2 pi or plus or minus 360. All right? So 150 plus 360 and 150 minus 360. So I get negative 210 and positive 510. Sorry. But the 7 pi over 6, that one's radians, so I have to use the 2 pi. So I'm going to have 7 pi over 6 plus and 7 pi over 6 minus. I need it over 6, and I want 2 pi, so what do I do with the 6? So it's 12 pi and 12 pi. So 7 plus 12 gives me 19 pi over 6, and this gives me negative 5 pi over 6. So the next one, negative 11 pi over 12, negative 11 pi over 12, plus, minus, it's over 12. What? 24. It is. It's close enough. So negative 11 plus 24 gives me 13 pi over 12. And this one gives me negative 35 pi over 12. Plus or minus 2 pi, pi over 180, initial and terminal, and all the 90s. Okay, one last thing is the reference angle. And this is here how the reference angle works. If this is my angle, if the pink one is my angle, the reference angle goes from the x-axis back to the terminal side. X-axis back to the terminal side. And that's your alpha, and that's the reference angle. Alpha. So the one thing about this is always positive. Even if it's backwards, the reference angle is always positive. Okay, so if theta is in the first quadrant, that is your reference angle. Anything from 0 to 90, that is your reference angle. So if I drew this and said, what is the reference angle? The reference angle is 60. It's in the first quadrant. Anything in the first quadrant is the reference angle. Okay? So theta and the reference angle are the same. In the second quadrant, if it's over here, I'm going to take pi minus theta, or 180 degrees minus theta. The angle. So this one I'm going to do the other way, theta minus 180, or theta minus pi. And the last one is going to be 360 minus theta, or 2 pi minus theta. It's super fun. You're going to love this. The reason I like it, y'all, is I know this seems like a lot, but really there's patterns to this whole thing. And once you learn the patterns, you don't have to, you do the same thing over and over, okay? So if I start with 150, 150 is over here. So my reference angle is here. So my reference angle is 30.
So you just subtract from how far it is from something.
That is, exactly.
So why did you go through all that beta and theta?
What did I just write here? 180 minus 150, what is it? Which is what I wrote.
You're saying theta, you're not saying 150. What is what?
Well, now it's 315.
Okay, what is that? Chime.
So where does that... Should I play the song again? I think I will, as soon as I'm done, yes. So 315 is going to be over here. So the reference angle is here. Okay? So if it's 315, I'm going to take 360 minus 315, and what do I get? I got 45. This is what I did. All right. Minus 240. So watch. Minus 240. So this is here. So where's the reference angle? From the x-axis to the terminal side. So right here, x-axis to the terminal side. So this one's a little different, isn't it? So how many degrees is this? Right here. It's not 240. It's 180. So how many are left over for the reference angle? 60, right? 240 minus 180 gives me 60. Okay, well, I skipped out this morning, and they all fell out of their chairs when I got to here. You got this, and now you don't want that. All of you make up your minds. Make up your minds. All right. So, now listen. So this is where it gets hard because 5 pi over 3. Where does that go? Okay, so listen. So we can convert that, right? We could do 180 over pi. But here's what I want you to think about. How many degrees is pi? How many degrees? 180. What's 180 divided by 3? Times 5? 300.
I don't know. My head hurts.
I was proud of you for getting that far. All right. Not today. Never again in this class will it be that. Yes. Okay, so my reference angle from the x-axis to here. Uriel, are you talking about this? Great.
So it's 60.
Okay, it is, but I want it in radians. So listen, how many, when I said all the way around was 360, what is that for pi? How many? 2 pi. So if I wanted it to be over 3, 2 pi would be 6 pi over 3, right? So if this is 5, how much is missing? 1. So the reference angle is pi over 6. Okay, shh. You guys, stop. Listen. So this was 5 pi over 6, and we found that's 300. So I know it's 60, right? But this is what I know. I know that all the way around is 2 pi. If it's over 3, 2 pi would be 6 pi over 3. If this is 5 pi over 3, how much is left to get up to 2 pi? 1 more pi over 6. Pi over 6 plus 5, or 3, sorry. 5 pi over 3 and 1 gives you 6. Yeah. So, listen now. What is 2 pi with a 6? How many? So that's one whole rotation, right? So I went all the way around up to here, and now how many more pi over 6 do I do? 1. So I have 1 pi over 6. So this is my reference angle. And what did we say about the first? So this is my reference angle, so this is pi over 6. I don't think I am. So 5 pi over 4. First of all, pi over 4 is 45 degrees. So, shh, just listen. Pi over 4 is 45 degrees. So how many 45s do I have in a 90? 2. But how many do I have altogether? 5. So if I do 2 here, 2 here, how many here? 1. Okay, just listen, would you please? Shh. So, if I went up to here, this is my minus 5 pi over 4. Does everybody see how I got up here? We counted. So, oh, thank God. Okay. So, I came all the way around to here. My reference angle is this. So, I have to subtract off pi this time, right? I have to take away pi. I have to take away 180 degrees. And it gives me this leftover amount. So what we've done is we added 180 plus 45, correct? So how much is left over? 45. So this is pi over 4. And this is probably the hardest part, and we'll keep working on this. But just so you know, right now, from the x-axis to the terminal side is the reference angle. And we'll keep working on finding it, okay? As long as you know that, you're okay.